video, I'll demonstrate the security assessment scanning that I did on Ubuntu using 3 tools, which is Linus, Nmap, and OpenVAS. So first of all, I will install my first tool, which is Linus, where it basically scans your Linux system and tells you how secure it is. To install it, I just ran this command, which is sudo apt install Linus. Next is my second tool, which is Nmap. So basically, it's used to scan for open ports on your system. Open ports can be dangerous because attackers can use them to get into your system. Tool is OpenVAS, which is also known as Greenbone. This one is more advanced compared to Linus and Nmap. It actually checks your system against thousands of known vulnerabilities. To install it, I ran sudo apt install OpenVAS. I ran this command, which is sudo gvm-check set. So to see if anything was set up correctly, and at first it showed some error. It said that the NVT collection was not found, so I had to fix that first. So to fix the timeout issue, I ran this command, which is sudo run user -u _ gvm --gvm -manage -certs -a and -f. So what it does is it regenerates all the SSL certificates needed for OpenVAS to work properly. After that, I ran again the command for gvm-check -setup, and I also ran into the same problem. So to fix it, I ran this command, which is greenbone -feed -sync --type nvt, which downloads all the vulnerability data from the Greenbone community feed. After that, I ran this command, which is sudo gvm-start to open all the OpenVAS services, but it showed something is already using port 9392/TCP. So when I tried to type in the website in the Firefox in Ubuntu, it shows the URL is not found. It could be because the GSAD is configured to serve HTTP only, or vice versa. Besides that, it could also be because GVMD is not running, which is the web server, and it is confirmed that the web server is running on port 9392. So in order to make it running, GSAD needs GVMD to be running behind it to serve pages. So since GVMD timed out and failed, GSAD has nothing to connect to, so it returns URL not found.
So in this part of the demonstration, I will explain the hardening techniques that were implemented on the Ubuntu system and the security assessment that was conducted after the hardening process. The first hardening technique used in this project is UFW, which stands for Uncomplicated Firewall. UFW was used to control incoming and outgoing network traffic on the Ubuntu system. First, the firewall was enabled using the command sudo UFW enable. Then, SSH access was allowed using sudo UFW allow SSH to make sure remote connection could still function properly. After that, the firewall status was checked using sudo UFW status verbose. The result showed that the firewall was active and incoming traffic was denied by default except for SSH connections. This helps improve system security by blocking unauthorized network access. The next hardening technique implemented was fail-to-ban. Fail-to-ban was installed to help protect the Ubuntu system from brute force login attacks. The package was installed using the App Package Manager and the service was enabled and started using systemctl commands. The status of the fail-to-ban service was then checked to confirm that it was running successfully in the background. Fail-to-ban improved security by monitoring repeated fail login attempts and automatically blocking suspicious IP addresses. The third hardening technique performed was SSH hardening. The SSH configuration file was edited to improve the security of remote access services on the Ubuntu system. Some unsecure settings such as root login and weak authentication configurations were modified to reduce security risks. After making the changes, the SSH service was restarted and its status was checked to ensure the service was still functioning correctly. This hardening process helps secure remote access and reduce the possibility of unauthorized login attempts. The fourth hardening technique implemented was ClaimAV anti-malware protection. ClaimAV and the ClaimAV daemon were installed using the App Package Manager. The ClaimAV service was then enabled and started successfully. Malware scan was performed on the system directories using the clamscan command to detect possible infected or malicious files. The scan summary showed that no infected files were found on the Ubuntu system. This additional layer of protection helps improve system security by detecting malware and suspicious files. After completing all the hardening techniques, another security assessment was performed using Linux and Nmap to evaluate the updated security posture of the Ubuntu system. The final Linux scan showed improvement in the system hardening index after the security configuration were applied. The malware scanner component was also successfully detected after the ClaimAV installation. This indicates that the hardening process improved the overall security of the Ubuntu system. Next, animal scanning was performed to identify active services and open ports after hardening. The scan results show that only necessary services such as SSH, IPP, and PostgreSQL remain active on the system. This demonstrates that the Ubuntu system remained functional while maintaining more control network exposure after the hardening process. In conclusion, the hardening techniques and security assessment performed in this project successfully improved the security posture of the Ubuntu operating system. By implementing firewall protection, intrusion prevention, SSH security configuration, and malware protection, the risk of unauthorized access and system vulnerabilities were reduced. That's all from me. Thank you.